Now this question is related to finding electric field due to the volume charge distribution. So this says we have a space, and in this space charge is distributed uniformly, not uniformly, it's a rho naught minus alpha to the power q. This is a spherically symmetrical. Discuss what is this. This means the charge is distributed in this whole region. So let us say plus charge we have. So this whole space contains positive charge. Are you getting? Now this whole space contains positive charge, and the charge density, volume charge density, is given by this function rho naught e to the power minus alpha r q. So you see, for a given r, rho is constant. So I have a one cell over which rho is constant. I have another cell after this that will have another rho, that is again constant. After this I will have another cell that will also have a rho that is constant. So I will have different cells that will have constant density. So I will get concentric cells that will have different density. So the density of charge only varies with, so I have this spherical cell, another this cell, another this cell. So let us say this is rho 1, this is rho 2, this is rho 3. So you see, this is radially symmetrical, only rho varies only with r. So this kind of system is called a spherically symmetrical system. So this is spherically symmetrical. So on one sphere the rho value is same. So this is spherically symmetrical. So I should have double M. Now let us see, whenever you have system is spherically symmetrical, I can apply the cell theorem. To find the electric field at any point, what we will do is, so let us say if I want to find electric field at this point, what I can do is the total charge in this sphere can be placed at center, and then I can find electric field at point P. So this is my point P. So if I want to find point P, what is electric field? So this is simple. I have to find total charge, and then I will apply q by 4 pi epsilon naught r square, that is total charge concentrated on the center. So this result is only valid if your charge distribution is a function of r only. So this result, that is, I can concentrate all the charge at the center of region only if rho is a function of r. This rho is not a function of theta and phi, and that's why I can concentrate all the charges of this cell at center. Again, all the charges of this cell can be concentrated on center. So this means the total charge in this volume can be concentrated on the center to find out the electric field at this point. And now the out charge will not contribute to the electric field at point P. So only I have to find this charge. So this charge will contribute to the electric field at P. The charge that is the outside will not contribute to the point P, because Gauss law says electric field at point P will be only Q inside. If I take this is a Gaussian surface, so Q inside by epsilon naught we will have. So my target is to find Q. So let us say I have a spherical cell. This is the volume charge. Just have to find what is the Q in this region. So what is the total Q? That I can find by integration. So let us say if I take a small dq region. So let us say this is a small cell. So what will be the volume of this cell? So this will be 4 pi. So let us say this radius is r. So this will be 4 pi r square, and this thickness is dr. So 4 pi r square into dr is the volume of this cell, into density rho, that will give me the dq. Are you getting? Now if I integrate this, so I will have 4 pi r square rho dr, and if I integrate this, let us say 0 to r. In this case I need this is a function of r, so let us integrate 0 to r. I will get the total charge. So we will have q is equals to 0 to r. 4 pi is constant, so I can take 4 pi outside, and r square, and rho is what? Rho is here. Rho naught e to the power minus alpha r q. So this is rho naught e to the power minus alpha r q dr. So this is my integration. Now only things we have the mathematics. So doing integration is the mathematics, not physics at all. So I will have q is equals to 4 pi, rho naught is also constant, e to the power minus alpha r q r square dr. Now if I take z is equals to alpha r q, this is 0 to r, alpha r q, so I will have dz is equals to alpha 3r square dr. Are you getting? So this means r square dr is nothing but, so r square dr is nothing but dz by 3 alpha. Now if you plug this value in the integration, so my integration is this 0 to infinity e to the power minus alpha r q r square dr. So this is my integration. So let us plug these values. E to the power minus z, because alpha r q is z, so e to the power minus z, and r square dr is nothing but dz by 3 alpha. So e to the power minus z, integration of e to the power minus z is e to the power minus z, and with a minus sign. Are you getting or not? Let us back to Pavilion. Z is a alpha r q. So if I plug the value, so this is 1 by 3 alpha, minus sign if I take outside, so this is e to the power minus z is alpha r q, and this is 0 to r. Now this will be minus 1 by 3 alpha when you have 0. So in that case you will have 1, and then this is r, so you will have e to the power minus alpha r q minus 1. If you observe the minus sign, you will have 1 by 3 alpha 1 minus e to the power minus alpha r q. So this is the integration value. So q will be, so you see q is basically here we have 4 pi epsilon naught. I have to also multiply, so I will have 4 pi epsilon naught divided by 3 alpha 1 minus e to the power minus alpha r q. So this is the q. So what will be the electric field? So electric field will be q by 4 pi epsilon naught. This is rho naught, not epsilon naught. Are you getting? So this is rho naught. You check here. So this is rho naught here you have. So this is rho naught. So q is what? Q is electric field is q divided by 4 pi epsilon naught r square into q. Q is this 4 pi rho naught divided by 3 alpha 1 minus e to the power minus alpha r q. So this is the electric field you will have. So if you cancel 4 pi, so you will have, so if you cancel 4 pi, this 4 pi, this 4 pi goes, so you will have electric field will be given as rho naught by 3 alpha epsilon naught r square 1 minus e to the power minus alpha r q. Now let us discuss two cases. First case, let us say alpha r q is much less than 1. There is a small number. Then I can use my this approximation. So approximation of e to the power x is 1 plus x square by factorial 2, that is 2. Similarly something like this. So I will take only two terms, that is e to the power x is approximated as 1 plus x. So this will become rho naught by 3 epsilon naught. There is alpha also, so there is alpha, not epsilon naught. So 3 epsilon naught alpha, let's go check here. So you have 3 epsilon naught alpha. So you will have rho naught divided by 3 epsilon naught alpha r square. Are you getting? And 1 minus e to the power x. So this is 1 plus nx. So if I write, so this will be 1 minus. So if I approximate this, so 1 minus alpha r cube. So 1 minus alpha r cube. So this will become rho naught divided by 3 epsilon naught alpha r square. And this is simply alpha r cube. Alpha r cube. So alpha alpha goes. And r square also goes, so we will have simply rho by 3 epsilon naught r. You see, this integration is quite interesting because this is independent from alpha as well as only depends upon rho naught. So this is rho naught by 3 epsilon naught r. So this is independent from value of alpha. And only depends upon radius, so linearly dependent on the radius vector r. So this is for alpha r is much less than 1, that is the r is r is small. So this is valid for a small r. Are you getting? Because we have considered this case when alpha r cube is much less than 1. This means for a small r. Now the another case, if we have situation 2, that is alpha r cube is much greater than 1. In that case, what we will do is, this is simple, electric field is given by rho naught 3 epsilon naught alpha r square and 1 minus e to the power minus alpha r cube. So if alpha r cube is much larger than 1, e to the power minus a large number, so this will tend to 0. So this will tend to 0 because alpha r is a large number, e to the power a negative number with a large number, so this is 0. So we will have rho naught e to the power, this e to the power goes, so rho naught 3 epsilon naught alpha r square. So this time electric field depends upon alpha as well as r as well as rho naught. So now this is a linear variation. This time we say 1 by r square variation, that is inverse square. So this is true for alpha r is much greater than 1. This means this is true for large r. So you see, for large r this varies with 1 by r square. For a small r is simply linearly variation, and for large r this varies with 1 by r square. So we can make a plot. So you see what kind of plot this will look like. So you can do yourself. So this plot looks like, so for a small r this varies linearly, but for bigger r that is varying 1 by r square. So this kind of plot you will have. So this is 1 by r, and this for bigger r this is 1 by r square. And this is same, so this kind of variation you will have in atom. So you see, we have already derived in atom what is the function for electron cloud. You have the same kind of function, some constant time e to the power. If you remember the wave function for s orbital, this is the same kind of function. You have some constant into e raised to the power minus, so that is exponential variation. So this kind of variation we have already seen. So that is the variation of rho, that is e to the power some constant. This kind of variation we have already shown in the atomic structure chapter. So you see, inside an atom it varies linearly. Oh sorry, this is not 1 by r, this is r. So in atom electric field initially varies linearly, and after that it varies 1 by r square. So you have an atom here. Inside an atom up to here electric field varies linearly, and after that it varies that is not linear, inverse square law. It will follow the inverse square law. So up to here, that is this region, linear variation. After that, this is a parabolic variation, 1 by r square variation. We'll discuss the next problem. I think all of you have copied this one. Good problem.